This is a continuation of the test 4 review questions. We're picking up with question number 10. And question number 10 asks us to find the inverse of the one-to-one function f of x equals 2 log base 7 of 3x minus 5 added to 9. Now, it's important to note that they tell you it's a one-to-one function, because if it's not a one-to-one function, there is no inverse. So it's important to note that. And remember, to find the inverse, we interchange x and y. But remember in this scenario that f of x is the same thing as y. So the first thing I'm going to do is interchange the x and y so that we have x equals 2 log base 7 of 3y minus 5 added to 9. The second thing that I want to do is use the exponent, the logarithmic properties, and this 2 that's in front of the log, remember, goes back up into the exponent position. So we would have x equals log base 7 of 3y minus 5 squared added to 9. Keeping in mind that my goal is to solve for y, I need to move the 9 to the other side to get the logarithm by itself. So I'm going to subtract 9 from either side. So I have x minus 9 equals log base 7 of 3y minus 5 squared. Then I need to deal with the logarithm. To undo a logarithm with a base 7, we're going to raise it to the 7th power. So we would have 7 raised to the x minus 9 power equals 7 raised to the log base 7 of 3y minus 5 squared. Continuing the simplification process, we have 7 raised to the x minus 9 power equals, remember, exponential base 7 and log base 7 will divide out. So I have 3y minus 5 squared. I need to undo the square. So to undo the square, I'm going to square root both sides. So we're going to take the square root of this side and the square root of this side. So we have 7 to the x minus 9 power equals 3y minus 5. Oops, I lost my square root symbol there. Sorry about that. All right, then we're going to solve that good old basic everyday equation. I'm going to add 5. So I have the square root of 7 raised to the x minus 9 power plus 5 equals 3y. And then the last step is going to be to divide by 3 all the way across. So we have 7, the square root of 7 to the x minus 9 power added to 5 divided by 3 equals y. And that y actually becomes f inverse. But one thing I want to point out to you is we can simplify this just a little bit, because remember that the square root, we really have, take this up here to the side for a minute, we really have 7x minus 9 to the 1/2 power plus 5 all divided by 3. And so I can simplify that a little bit if I use that fractional exponent, and I get 7 raised to the 1/2 x minus 9/2 plus 5 all divided by 3. And that's going to be my F inverse. Again, using the fractional lexicon, it kind of makes it a little bit simpler, so that's probably the better way to go. All right, number 11 asks us to solve the equation log base 5 of x plus 3 minus log base 5 of x minus 2 equal to 1. And the first thing I think I want to do with this one is I noticed that the two logs are being subtracted. So I want to write this as a single logarithm using the property. And remember that subtraction becomes division. So this would become log base 5 of x plus 3 divided by x minus 2, and that's equal to 1. Then to solve that, we need to undo the logarithm. To undo the logarithm, we're going to raise it to the 5th power. So we would have 5 to the log base 5 of x plus 3 divided by x minus 2 equals 5 to the 1st. Again, remember that log base 5 and exponential base 5 will divide out or will cancel off because they're inverses. So we have x plus 3 over x minus 2 equals 5. And technically, that's 5 over 1, so that you have a fraction equal to a fraction, which we solve by cross multiplying. Okay, so if I cross multiply here, I have 1 times x plus 3 equals 5 times x minus 2. Distribute and collect like terms. So I have x plus 3 equals 5x minus 10. I'm going to get all the x's together and all of the numbers together. So I'm going to, let's see, subtract x. So I have 3 equals 4x minus 10. I need to move the 10 to the other side. And to do that, I'm going to add 10. So I'm going to add 10. So I have 13 equals 4x. Finally, I'm going to divide both sides by 4. So I have 13 fourths equals x. Now, I do need to be careful because remember, the argument within the logarithm cannot be negative. So 13 fourths plus 3 is still going to be a positive number, so I'm good there. 13 fourths, which is 3 1/4 minus 2, is still positive, so I'm okay. Okay, you want to make sure that your argument's going to be positive. All right, the last one, or number 12, says polonium-210 has a half-life of 138 days. Assume a company buries 500 grams of polonium-210 underground. Find a mathematical model for the amount of polonium-210 left underground after T days and use it to determine what would be left after 1 year. And round your answer to the nearest tenth of a gram. Okay, now remember, when you're talking about a mathematical model and you're talking about radioactive decay, that we base that on the continuous compounding formula, which is A equals P E to the RT. And in this scenario, the first thing we're going to have to do is find the rate of decay. So the first thing we need to do is find R. So we know that we start out initially with 500 grams. We also know that it has a half-life of 138 days. So in 138 days, we'll have half the amount, which would be 250. Okay, so you get the equation 250 equals 500 E to the R times 138 because you're told that the half-life was 138 days. Okay, so then I need to solve that for R. And to do that, first thing we're going to do is divide both sides by 500. So I have 250, that's basically 1/2, equals E to R times 138. I need to undo the base E. The inverse of base E, if you'll recall, is the natural log. So we have the natural log of 1/2 equals the natural log of E to the R times 138. Okay, so kind of continued working without really doing the calculations yet. Okay, so we have natural log of 1/2 equals natural log base E, cancel off, so I have R times 138. Remember, I'm trying to solve for R here. So I divide by 138. So natural log of 1/2 divided by 138 is R. So that gives me my rate of decay. And I'm going to leave it like that because that's the exact value. Then I need to go back and write a second equation to answer the actual question, which was how much will be left in a year. So we don't know how much is left at this point. We know we started with 500. We have E, and then we have natural log of 1/2 divided by 138. That represents R. And then we're doing a year, which would be 365 days. And we need it in terms of days because our R value is in terms of days because of the half-life. And then quite honestly, guys, this becomes a calculator problem. You're going to have 500 E, and then let's see if we can do the calculations and get the R value here. Okay, so we would do the natural log of 1 divided by 2. So natural log of 1/2 divided by 138 times the 365 days. Okay, so it becomes E to the negative 1.83. Okay, 1.83. And then we do those calculations. So we want to do 500 times E, so second ln of that big long decimal number that we just calculated. And we end up with 79.9. And we round to one decimal place because that's what they ask us to round to. Okay, you want to make sure you put your units in there. And so we start out with how many grams? 500 grams. So we end up with 79.9 grams. And you are asked on the actual test to put in those units, so you want to make sure that you do that.